In this video, we're going to continue our foray into the murky world of trigonometric proofs. So we're going to look at the addition formulae for sine, cos and tan, how to apply them, and what sort of questions you might be looking at using them in. These are very popular in the non-calc section of exams, so you need to be quite fluent with their use. So what are the addition formulae? Well, what it basically looks at is how can you use the sum of two angles or the difference of two angles to find maybe like an unknown angle. So an example of this would be we want to find what is sine A plus B, where these are two angles. Now you might think, well, why do we do that? Why don't we just add A and B and then find the sine of it? But if we don't have our calculators and the sum of A plus B is something unfamiliar, like maybe 115 or 75 or something like that, what we can do is break it down into a sum of two familiar angles. So for example, 75 we can break down into 30 plus 45. Now we know how to find the exact values of sine of 30 and sine of 45. So we can use the formulae and break it down like that, and then we don't need to refer to our calculators. We can do it in our heads, which is pretty handy. So just a warning before we start. There's a really common misconception with this that you kind of treat it like algebra, and it's not, or at least it doesn't behave like normal algebra. So if you have sine of A plus B, that does not equal sine A plus sine B. Okay, you cannot multiply, like take the sine through the brackets as though that were x or something like that. Okay, so please, please, please make a note. Does not. Okay, does not equal. Alright, so don't panic in an exam and suddenly think, oh, it's okay, just multiply it through the brackets. Alright, please make note of that. Okay, so what does it equal, now that I've showed you what it doesn't equal? So these are our addition formulae. Now, I could show you the proof for doing these, and if you are interested, then certainly go to the textbook. They do go through the proof in quite a nice sort of detailed way. However, it's not necessary. It's a little bit complicated, and I don't really want to run the risk of just confusing everybody. So I'm not going to show you the proof for these ones. When we come to some of the formula a little bit later on, the proofs are simple, so I will go through those. So this is one of those things in maths where you just kind of accept that mathematicians that have come before you have done the hard work, they've proved that this works, and you can just accept it as fact. Okay, you don't need to memorize these. These usually turn up on your formula sheet in an exam, but you do need to know how to use them. And if you can memorize them, it is quicker, obviously, and you need to be able to recognize the questions that you need to use it in. So what it says is if you've got two angles, u and v, and you want to add them together, sine u plus sine of u plus v, then that is equal to sine u cos v plus cos u sine v. Okay, and if they're subtracted, if it's a difference, then it's the same, but there's a subtract sign in here. Sine u cos v minus cos u sine v. Okay, so it just means if this was 30 and this was 45, you'd substitute in 30 here, and 45 here and here, which I think is exactly what we're about to do. Let's go and have a look at the first example. Oh, look at that. Okay, so our first question, we've got sine of 75. Okay, now I want to break that down into something that I know how to find the sine of without using a calculator. So 30 and 45 is going to be the go. So sine of 30 plus 45. Okay, haven't changed anything, just split this up. So now we're using an addition formula, and I know from my formula that's going to be sine of the first, cos of the second, plus cos of the first, sine of the second. Okay, now if you have to refer back to your formula, please do. Don't get it wrong. So go back, check it, yes, substitute it all in correctly, and come back here. Okay, now we know from our exact values that sine 30 is a half, cos 45 is 1 and root 2, plus cos of 30 is root 3 on 2, and sine of 45 is of course 1 on root 2. Alright, multiply that out, 1 on 2 root 2 plus root 3 on 2 root 2. Okay, so that's pretty straightforward. 1 plus root 3 on 2 root 2. Now if I want to rationalise the denominator, and the textbook is pretty big on rationalising the denominator, you just multiply by root 2 on 2 to get rid of this root 2 over here. Okay, and if I do that, what I will end up with is root 2 plus root 6, because of course root 3 times root 2 is root 6, so I've just multiplied that by all of that. And then root 2 times root 2 is 2, then 2 times 2 is 4. So that's my answer there. Okay, so it's still kind of a little bit non-meaningful. It's a bit messy, but it's in a nice exact form, so I've got a nice exact answer there. Okay, so that's for the first one. For the second one, it's very similar. I'm just going to do it over here, except we're going to use a subtract this time. So I'm going to say, well, 45 minus 30 gives me 15. Okay, so the formula is slightly different, pretty much the same, but we've got a minus. So sine of the first, cos of the second, cos of the first, sine of the second. Okay, so sine 45 cos 30 minus cos 45 sine 30. Okay, and because the numbers are all the same, if we work it out, in the end what we come down to is root 6 minus root 2 over 4. Okay, and you can go through that and satisfy yourself that that actually is the correct answer for that. Okay, so that's for sine. Right, for cosine, so same thing, u plus v or u minus v. So this one is cos of both, so cos of the first, cos of the second, minus sine of the first, sine of the second. So these are opposite signs here. Okay, and then here it's cos of the first, cos of the second, plus sine of the first, sine of the second. Okay, so you will eventually find yourself memorizing these, even if you don't really want to. It's the kind of thing that sticks in your head. Okay, but all you're doing really is just substituting. So if we have a look at an example for this one, so cos 75, good old 75. Okay, so same sort of thing here, 75, once again, is 30 plus 45. There we go. Okay, so if we have cos of 30 plus 45, we know it's going to be cos of the first, cos of the second, minus sine of the first, sine of the second, and that will give us root 3 on 2 times 1 over root 2 minus half times 1 over root 2. And again, that actually turns out as the same as part B that we just did, which is minus 6, so root 6 minus root 2 over 4. Okay, so a little bit of mucking around here with your, playing with your surds and things. It's always good practice. Okay, so the actual math behind that should be fairly straightforward. Okay, tangent's slightly more complicated. We start introducing fractions, but same principle applies. You've just got a formula and you just want to substitute values in. So we've got tan of u plus v is tan u plus tan v over 1 minus tan u times tan v. And then for when you're subtracting, you just swap these signs. So positive becomes a negative, negative becomes a positive. Okay, so just making sure that you've got everything the right way around. But as I said, this usually turns up on your formula sheet, so you can always refer back to that. So the example that we've got here is slightly different. Okay, so it's saying if u and v are acute angles, and you know that tan u is 4 and tan v is 3 on 5, show that, so it's given you the answer, show that u minus v is pi on 4. So this is a bit of a proof. Okay, so u minus v, well that kind of tells me, and the fact that I've got tan u and I've got tan v kind of tells me that what I need to do is find what is tan u minus v, because if I can find that, I can find the inverse of that to find what is u minus v. Okay, so tan of u minus v, using our formula, is tan u minus tan v over 1 plus tan u tan times tan v. And I have those values, so tan u is 4 minus 3 on 5 over 1 plus 4 times 3 on 5. Okay, and if you work that out, it actually comes out as 1. Alright, so now what we're looking at is, well, that's tan u minus v equals 1. So if I want to solve for u minus v equals the inverse tan of 1. Okay, and we know that the inverse tan of 1 is pi on 4, or 45 degrees, but it asks it for it in terms of radians. Okay, so just a slightly different application of the formula there. So in summary for this video, it's not necessary to memorize the formulae, but you do need to know how to use them. One of the big things is recognizing questions that need the use of the formulae. To start with, when you've just got your additional formulae, it's reasonably straightforward because that's the only thing you need to know, so it's only deciding whether it's sine, cos, or tan. However, there are double angle formulae, and then there are other various identities, and it does get a little bit messy, and you need to get quite good at picking which one you are going to use. So do practice these until you become fluent. Don't panic and treat them like regular algebra. Okay, don't multiply them through the brackets. You can't do that. Like I said, these typically turn up in the non-calc section of exams. So you'd find the sum or difference of these angles. So you might have like 105 for 45 and 60 or something similar. So if you practice them, you'll be well versed by the time you get to doing them in the exam.